We're going to talk about the fundamental counting principle, or basically how we count up the ways in which something can happen. Some things that we count in life, we just have to count out the number of ways, very simply. So Anna's going to roll a fair pair of six-sided dice. So we've got two dice over there at the right. Again, they're six-sided. They're numbered from 1 to 6. And how many ways can she roll a sum of 12? Well, if we kind of picture all of the different possible ways in which we can roll these dice, right? Let's say we've got a white dice and a blue dice here in our chart. All of the different ways that we can roll a 12, right? Well, the only way to roll a 12 technically is just a 6 and a 6, right? So again, all we can do there is just count up the number of ways in which that can happen. But now Hallie's going to roll a fair pair of six-sided dice. How many ways can she roll a sum of 4? Well, we could roll a 1 and a 3, right? So a 1 on the blue dice and a 3 on the white. We could roll a 2 and a 2. Or technically, because it is different, if we rolled a 3 on the blue dice and a 1 on the white dice, that's a different number of rolls, right? Now, again, the 2 and 2 can't really switch because, again, if you've got a 2 on the white and a 2 on the blue, that's not different from a 2 on the blue and a 2 on the white, right? That's the same thing. So realize in this case, that's going to be 3 ways. And you'll notice on the chart, those things kind of work out in a nice simple pattern. Grace is going to roll a fair pair of six-sided dice. And how many ways can she roll a 9? Well, again, if we take a good look, we could do 6 and 3. We can have 5 and 4. Again, 4 and 5. Or 6 and 3 the other way around. And therefore, again, there's going to be 4 ways we can do that. Again, there's just certain things that when we count them out, we're just counting the number of ways they can happen. Now, there are shortcuts, though, depending on how the question is worded. Down here at the right, and how many total ways are there to roll a fair pair of six-sided dice? Well, we could just count up everything on the chart, but really what we can say is, well, there's 6 ways to roll the first dice, and there's 6 ways to roll the second one. So it makes sense if you take a good look at our chart, 6 by 6, there are 36 total ways, right, to roll a fair pair of six-sided, or pair of six-sided dice. Well, how about 5 dice? Well, I don't want to really draw out the table for that, right? But I know that there's 6 ways to roll each one of those die, right? So again, it'd be 6 times 6 times 6 and all the way down the road, or basically 6 to the 5th power, right? And that's going to give us a pretty big number. So I'm going to grab my calculator real quick here. And we'll figure out that that's 7,776, right, possible ways to roll 5 different dice, right, to kind of match up 5 different dice. Again, the idea of multiplying basically goes to what we call the fundamental counting principle. If you have an event E sub 1 here, right, you have one event that can occur M ways, and E sub 2 can occur M sub 2 ways. Well, then the ways that they can occur together are basically just multiplying the two, M sub 1 times M sub 2. So, a couple of simple examples here for you. How many ways can you have a basic license plate possible if there's 3 letters and 3 numbers? Well, again, we're going to have sort of 6 slots, if you will, in our license plate. I can get any one of the 26 letters, right, in that first slot. And I'm going to do 3 letters in a row. And I didn't say there's any other restrictions, so I could have any one of the 26 letters here, or any one of, again, the 26 letters there. And again, I'm going to multiply those 3, because that's the fundamental counting principle. There's 26 possible for the first event, 26 possible for the next one, and 26 essentially to the third, right, possible ways to have 3 different letters. But then again, we're going to be followed by 3 numbers. Well, the numbers 0 to 9, there's 10 total digits. So again, we can say any one of the 10 digits in any one of those spots, or basically 10 to the third. And if we take 26 to the third times 10 to the third, right, or essentially times 1,000, we know that there are 17,576,000 possible license plates that can be made with 3 letters and 3 numbers. Okay. Well, let's just say, well, California wasn't big enough, right? California's got a lot of cars, a lot of people. If we decide the 3 letters in the number weren't enough, right, we're going to precede those 3 letters with a number from 1 to 9. So now we're going to say, okay, well, we've got 7 slots. We can have any one of those 9 numbers. Then we can have the 3 letters. Right? Then we can have our three numbers, right, which we had no restriction on. We could also have zeros in those. So now we're basically going to take our previous number times another 9 and just putting one more, right, 1 through 9 number in front of them, one more digit. We now have 158 184 000. So basically 158 million license plates. So again, just that one extra digit, it made that number kind of skyrocket, go up really quickly here. Well, here's a slightly different question. Remember, in the license plate, it didn't really matter if we repeated any numbers or repeated any letters. But down here at the bottom, what if we have 7 people and we want to sit them in 7 chairs? Right? 1, 2, 3, 4, 5, 6, 7. Well, any one of the 7 people can sit in the first chair. So I'd say we have 7 options, right, of people who can sit in the first chair. But once someone's seated, right, we can't really seat that person in another chair. We only have 6 options to sit in chair number 2. And the same thing goes, we've already seated 2 people and 3 people. So again, we're getting fewer and fewer people by the time we get to that last chair. Or basically, that's what we call, again, 7 factorial, right? 7 factorial is just 7 times 6 times 5 times 4 times 3 times 2 times 1. And basically that comes out, we're going to have 5,040, right, possible ways, possible seating charts, if you will, possible ways to sit 7 people in 7 chairs. Let's take a look at one more example here. What about if we're talking about phone numbers? How many 7-digit phone numbers are possible? Well, with no restrictions, if we're not saying we have any restrictions at all, if we're just going to simply say, okay, any one of the 10 numbers, right, 0 through 9, in any one of the spots, basically we can just say, well, there's 10 times 10 times 10 times 10 times 10. Basically, there's 7 spots. I'm just going to go ahead and say 1, 2, 3, 4, 5, 6, 7. There are 10 million possible phone numbers then. But now remember, we don't really want to put a 1 first because that would make us dial international, or if we put a 0 first, right, that's going to take us to the operator or kind of do some weird things there. So what if we can't have a 1 or a 0 in the first digit, right? Well, now 7-digit phone numbers. Well, we can only put any one of 8 numbers then, right? I can't use 0 and 1. Then I can have the other 6 of them, right, with any possible numbers that we want. So basically that's going to be 8, and then again 1, 2, 3, 4, 5, 6. Just limiting that alone, we just dropped 2 million possible phone numbers off of our list. Well, same idea. How many 7-digit phone numbers are possible if we attach an area code? What if we attach any one of 4 area codes here? Well, now we have 4 possible area codes, right? We still can't start with 0 or 1, so again, it's any one of 8 numbers for that first of the 7-digit numbers. And then we've got 6 more, right, numbers on there. So now we basically took our previous number times 4, we've kind of quadrupled it, and we've got 32 million, right? All those zeros coming from that 10 to the 6th, 32 million possible numbers in that case. But again, the idea is whatever that first event is, whatever that first idea is, we multiply the number of ways that can happen by the number of ways that any of those other things can happen. That's the fundamental counting principle. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.